Well, look at us, we're already on Unit 3, Modeling with Graphs. And we're doing Lesson 1 today, which is graphing in 4 quadrants. So what does that even mean? This is a Cartesian plane. This is René Descartes. So if you take the DES off his name, Cartesian plane, that's named after him. So he's a French philosopher, mathematician. I think he's also the guy who said, I think, therefore I am. Anyway, this is a Cartesian plane. So what he did was he took a grid, a plain old grid, like something like this, and then drew an X and Y axis through it so that we could kind of use it to plot things. He's got an X-axis, which is the horizontal one is called X, and the vertical axis is called Y. So the axis just means those dark lines. Those are the axes. The plural of axis is axes, A-X-E-S. The very center of them where they meet is called the origin, and that's a really important part. It is where we start counting from all the time. Everything is based on that point. The Cartesian plane is divided into 4 quadrants, and the numbers are coming up there. They are in capital Roman numerals, and they are labeled counterclockwise. The first quadrant is this one here. So always remember the first one is the top right, and then 2, 3, 4. It goes around this way, and it always goes around that way. So that's as soon as you draw an X and Y axis, then you have it divided into 4 parts, right? 4 quarters or 4 quadrants. Let's plot some points on the Cartesian plane. 5, 6, that's an example of an ordered pair. So we use different phrases for this kind of thing. Sometimes you'll hear me say ordered pair. Sometimes you'll just hear me say point. And sometimes you'll hear me call that a coordinate. So a coordinate has 2 parts to it. There's the X coordinate, the X part of the coordinate, and there's the Y coordinate. And together we just sometimes say a coordinate. So how do we figure this out? So the first X coordinate is a 5. So we go from 0, we go across, this is the X, so we go across the X until we get to 5. Then we figure out the Y coordinate. It's a 6. So here's my Y axis. So my Y is my up and down number. So I've got to go from here, I've got to go up 6. So there is the point 5, 6. It's the ordered pair, it's the coordinate 5, 6. So this is a little trick that some people it helps them remember. It's like entering a hotel. So the first number is going in the door of the hotel, and then the next number is you're going up or down the elevator. So here is your entrance of the hotel, the origin, 0, 0. So when we have a number to put in there, like -3, 4, we start at 0, 0, and first we walk in the door. So we have to walk to the elevators first. So that's that direction this time because it's left 3. There's your little pointy finger. There it is, there it is, there it is. Left 3, that's annoying. Now we go up 4. We're going up the elevator, up, 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 -3, 4. So that is one way to kind of try to remember which way to go first. Students do mix them up sometimes. So let's try one here. We want to put an A on the spot that is -4, 6. So first we have to go sideways. -4 is to the left, and then 6 is up. We put a dot there, and there's -4, 6. How about 2, 3? Okay, you're going to go which way? Think about it. To the right or to the left? Remember, you're always starting here. You're starting here. You're going to go 2 units. So, well, these are your options. 2 this way, 2 up, 2 left, 2 down, or 2 right. And only one of those answers is correct. Which way are you going to go first? You're going 2 to the right, and then you're going down 3 because of the -3, and that gives you your point B. Point C is -6, -4. So remember, the X is first. This is my X-axis, so I have to do my sideways motion first. So from here, I have to go -6. That's in this direction. And then -4 means I have to drop 4. So I go there, and I put my point there as -6, -4. Let's do one more. D is 7, 3. So D, 7, 3, where's that going to go? First of all, the 7, we do that first. And that's the X, that's our sideways movement. So it's going to be to the right 7, to the right 7, and then up 3. And there's our dot at 7, 3. These points all lie in different quadrants. What do you notice about their coordinates? So right now, if you've got your handout in front of you, you'll notice that you're not copying anything down yet. We're just kind of watching this. I'm just kind of giving you a review first of these terms. So this is this part, there's nothing for you to write down yet. But what we notice about the coordinates is that some are positive and some are negative. We're in quadrant 1 here, both of them were positive. And that's why this is quadrant 1. That's why it's the first quadrant, because everything is positive here. And that's what we kind of like the most, right? The positive ones are easy. So this is quadrant 1. Then when we move to the other coordinates, different parts of the coordinates will be negative depending on what quadrant we're in. Plot the following points. Okay, this is a new one. 5, 0. 5, 0. So my x is a 5. So I know that from here, I'm going to go over 5. But then what do I do about this 0? My y value is a 0. How am I going to move 0? There's over 5, but that's it. I'm not going up or down anywhere, so that's where E goes. It stays right on the x-axis. And F is 0, 6. This time my first number is a 0, so normally my first thing I would do is I would go sideways. But because my first coordinate is, and my x-coordinate is 0, that means on the x-axis I'm staying at 0. I'm not going anywhere. I'm staying at 0. And I have a y value of 6, so that's going up to 6. So there's F. How about G? Negative 7, 0. Again, start with your x. The x, we start at the origin here. I need to have an x value of negative 7. So that means to the left 7. And then a y value of 0. So I'm just going to stop there at negative 7. I'm not going up or down. Let's do one more like that. H is 0, negative 3. Hopefully you're getting the hang of this. You can point with your finger right to your screen right now if you know where it is, and I'm going to show you where it is. Hopefully you got that spot right there, 0, negative 3. These points all lie on axes, not in there's a plural I was telling you about. They all lie in axes, not in quadrants, because they're directly on the lines. So what do you notice about their coordinates? Well, they all have a 0 in one spot because they didn't move into a quadrant. They were held directly on the axes. Mathematicians have, so this is on your handout now. So now you can start looking at your handout. I'm reading the very top paragraph. Mathematicians have developed many powerful tools to help solve problems. One of them is the number plane, also known as the coordinate plane. So we're going to do some highlighting here. Sorry. Okay, the coordinate plane, I'm going to highlight that. The coordinate plane is this thing right here. That's a coordinate plane. That's the same thing as what we called the Cartesian plane earlier. It's also called the coordinate plane because we put coordinates on it. So we're just going to highlight on your handout there some of these definitions. That's a coordinate plane. The next little paragraph is the numbers in an ordered pair, such as negative 4, 5, are used to locate the position of points on a grid. So we're going to highlight ordered pair. And coordinate is also, as I said earlier, we use both of those terms to talk about the same thing, a coordinate. Well, I'm just going to get my pen tool out here, and I'm going to put a dot on negative 4, 5. So negative 4, I'm going to the left 4, and I'm going up 5. There's negative 4, 5. So negative 4, 5, that's called an ordered pair. That's very formal. I don't use that phrase very often. More often I'll say that's my coordinate, or that's my point. So highlight those words that are in bold. Then I'm going to skip that one paragraph you've got and go down to the next one. The grid with a horizontal axis and a vertical axis is often called the Cartesian plane, after French mathematician René Descartes, who invented it. So this whole thing is called the Cartesian plane. So those are vocabulary terms that you must know, and you must know how to spell them correctly. So highlight those and make sure you understand what they all mean. And remember, as I said earlier, the Cartesian plane, the quadrants, the first one is here, Roman capital numeral 1, 2, 3, 4. It has to go in that order there. So let's move on to some key ideas. The coordinate grid is often called the Cartesian plane, so I'm going to highlight that. When you spell Cartesian plane, make sure you put a capital C on Cartesian because that's after Descartes, so that's why it gets a capital C. So this thing here on your left is a grid. It's not divided up yet into the Cartesian plane. The axes, that's the plural of axes, they divide the plane into the 4 quadrants. So those 4 quadrants come from drawing lines, right? Now it's in half, one more line, and now it's in 4. So our 4 quadrants are, let me label them here. The first one in the top right is quadrant 1. Then we have quadrant 2, capital Roman numerals, quadrant 3, and quadrant 4. Remember, lowercase Roman numerals for 4 would be like this, right? So we don't want lowercase, we want uppercase, capital. The next point on your list here is the point where the axes intersect is called the origin. So the origin, let me put a dot on here, the origin is right there in the center. That's the origin right there. Origin, now let's write it here, origin. Origin, that's the origin. And the horizontal axis is called the x-axis, so I'm going to label that with an X. That's important. And the y-axis gets labeled with a Y. Sometimes we use different letters when we get into word problems, but otherwise you must label them. The next bullet, the ordered pair of numbers that identifies any point is x, y. X is first, y is second. Okay, that's the term ordered pair is pretty formal. We don't use it too much, but I might call that just a point or a coordinate, but we have to put x first and then y. The x value of a point is the x coordinate and is always written first, always. The y value is second. It's alphabetical here. Don't mix them up. The coordinates of the origin are 0, 0. Let me put that on here. The coordinates of the origin are 0, 0. That's the coordinate there of the origin. So let me highlight that as well, actually, that's the coordinates of the origin are 0, 0. A dot is used to represent a point on a graph. A capital letter is used to name the points. So I'm going to graph this point. I'm going to plot this. But first, I need to get a scale on my axes. So right now, if I look at my x-axis, it's just plain straight across there. It doesn't say what I'm counting by. I'm going to count by ones. So I'm going to label first, let me change that to orange actually, because that kind of matches better. 1, 2, and so on. So I have to do this. If you don't do it and you just put points on, then when I'm marking it, I might say, oh, well, I think he hasn't labeled his scale. I think he's counting by tens. And then your answer will be wrong. So don't let me guess. Label it for me. Across the negatives, -1. Now, what you can, well, I'll show you the y-axis actually. So let's just finish the x-axis. -4. You have to label the space that you're using. So I can't just label the first 2 axis lines, grid lines. I have to keep going. Now I'm going to label my y-axis, but I'm going to count by ones, but I'm going to label every second one. So look up the y-axis. I'm going to make my first mark here, and that's at a 2. So I'm still counting by ones, but I'm only labeling every second one, and that's okay as long as I'm consistent all the way, which means when I go down on the y-axis, now I also have to count by negatives. So -2. Count by 2s. So I can't now start doing this, labeling every one, because I didn't do it on the upper part of the y-axis. So I'm going to erase the -3 and the -5. The other thing that you can do is you could write them on the left side, but so I'll put -6 here and -8 here. But what I've done is wrong because I've switched sides halfway through. But you can switch sides right at the origin. You don't have to put them all on the right or all on the left. So, from the top to the bottom. But I am going to on one side they all have to be the same. I can't switch halfway through and switch over to the left side, so I have to go all the same. Okay, so I've labeled my axes, and now I'm going to put on this point A, which is at -4, 5. Okay, -4, 5. So the first is my horizontal coordinate. That's my x value. So on my x-axis, I have to go to -4. So that means I'm going to go left 4 from the origin. I'm going over 4 to the left. Normally you wouldn't draw that line. I'm just putting it in there. And then my vertical coordinate, or my y, is a 5. So I have to go. I'm going up 5 because it's positive. So I'm going to go up 5 here. Again, you would not normally draw these lines, and I'm going to put a dot right here, and I'm going to label this as, because that's what the question said, it said it's a capital A, -4, 5. Now, if you're looking at your handout, you'll see that there's some questions below here, 1, 2, I skipped 3, 4, 5, and so on. If we were in class, we would go over this together, and I would be asking everybody to go through this, and we would all kind of orally go through those questions to make sure everybody understands, but we can't, so you're just going to do that part on your own. And then when you flip to the back of your sheet, or page 2, that's what our next slide is. So here's our next one, definition. An equation is linear if its graph is a straight line. I mean, not a curve. Without graphing, you just look at the equation. So if I ask you if something's linear and you don't have a picture to look at, you look at the equation. If there's no x in the equation, or there is an x with only an exponent of 1, and you now know that means a degree of 1, then it's linear. So here's an example. This is linear. And this is maybe something you've never seen before, but if you see this equation, here's a y, here's an x, and it looks like this, then you know it's going to be a straight line. Also, if it doesn't have a constant, but it just has the x term, then it's going to be a straight line. Or if it doesn't have the x term, but it just has a constant, that's also a straight line. If we had an x to the power of 2, like a squared here, then it would not be linear. So linear means when you draw a graph, it's going to be perfectly straight. We are going to try that out right now. So here's an equation. I already know it's going to be linear because I just told you how to identify that. So I know it's going to be a straight line, which is a good check for me when I'm done. If it's not a straight line, I made a mistake, because by definition, this form is linear. So how do we graph it? How do we get a line on here? Here are the steps. The first is a table of values. So a table of values in elementary school, you might have called it a T-chart. So I'm going to draw in. So normally you would use a ruler. It's very hard for me to use a ruler on my drawing tablet here. It skips a lot. So I'm not going to use a ruler, but I would like you to. So I'm going to draw down here below number 5, I guess. I'm going to draw kind of like a T-chart here and here, like that. And my first box here is x. That's the first part, the first cell of my T-chart is an x. Across the top, my next one is the equation, this equation right up here. Y equals -2x plus 1. So you're writing this down as well. You might not have much room on your page. You might need your own piece of paper for this. It'll be a bit crowded. I'm writing the equation there. So that's the first thing. The next thing it says I'm still on step 1 here, is to select these x values. That means underneath my x column, I'm going to put, now this is where I get crowded, -2, -1, 0, 1, and 2. Okay, they have to go in order low to high, even it looks opposite there, but you have to start with the -2 because it's the smallest number and you go up to the 2. Okay, now my next step is to sub into the equation. Okay, sub into the equation. What does that mean? So here's my equation again. I'm going to circle it again here. I have to sub into the equation. See how my equation has an x in it? Well, I just listed a whole bunch of x's. So everywhere I had an x, I'm going to sub in with that. So let me write it. I'll write it first in red. So I've got y equals -2. Now in green, I'll put the number I'm substituting in, which is, instead of x, -2. So instead of this x right here, I'm putting I'm putting a -2, and then I'm going to write, +1 next. I'm going to close my bracket, and then back to +1. So that's my original equation subbed in. So I'm on this step right here, sub into the equation. So I don't have much room, and I have to do something that is really bad right here, which I'm going to write beside my equation. I should not be doing that. Normally I would give myself more space. So -2 times -2, that's going to be a 4. So that's actually, let me just make this look a bit better here. Let me erase this equal sign, and I'm going to put kind of an arrow here to show that I'm doing my next line. So y equals, so this is my y, I just wrote that y equals -2 times 2 is +4, and then +1 goes next, +1. Okay, so that's that step. Now that gives me y, oops, wrong color, sorry. That gives me y equals 5. Change that to red, so I get y equals 5. Okay, that's what I got from this equation. Again, up here at the top, from this equation right here, I subbed into x, which, there it is right there. There's my x. I subbed into x. Where did I get the x from? Right here. Right here. That's where I got the x from, and I subbed it. So let me erase all of this because I'm going to do it all again for the next question, and I don't want to have a whole bunch of extra little gimmicky lines all over the place there. Okay. So next one. So again, I'm still on this second part here, sub into equation. Now I'm going to do -1. I'm going to sub in a -1. So I have y equals, first is this -2. There's that -2. Now instead of x, I'm putting -1. So I'll put that in green to show that I'm substituting that in for x. Always substitute using brackets. Now this +1, I'm writing these two things next here, +1. So that gives me, so my next line is y equals, so -2 times -1 gives me a 2, and then this +1 is here. I'm just doing the order of operations. That gives me y equals 3. Okay, you're getting the hang of this now. I'll do one more with you, because 0 is kind of a neat one. I'll do one more with you, and then I'll let you do the next two on your own. So y equals, I'm going back up to the equation, y equals, so the first thing, let me erase this stuff here. The first thing I have in my equation is, so this is the equation I'm doing right here. This whole piece right here is what I'm subbing in. So I've got my y, I've got my equals. Now I'm going to do my -2. There's my -2. Now instead of x, I'm putting 0 this time. Always substitute with brackets, 0. Now I'm putting in the plus and the 1, +1. So this one's even easier to do. That all makes the line y equals -2 times 0 is 0 plus 1. So I get an answer of y equals 1. Okay, so press pause and do the next two, and when you come back, it will be all written down for you. Okay, welcome back. I hope you got all the answers that I got. So we found all the y values. So that was just step one, was to find all the y values, and here they all are. We got y values because we subbed in for x here. All these x's came from over here, and we subbed them in and we worked them out. And normally we would put lines underneath, right? But I ran out of room, and I know your sheet doesn't have room either, so this is okay. So that's only step one, but that's the big step. Step two is to write the coordinates. So what is this? How do I get a coordinate out of this? Remember what the coordinates look like? This does not look like a coordinate. These are just y values. Coordinates have to have an x and a y. So what would the x be if if I've got all the y's, where do I get the x's from? Oh, I know, from right here where we were told to do this right at the beginning. We were told the x values we needed. So we were given the x values and we had to figure out the y values. So that's what we just did here. So I'm going to write these as coordinates and I'm going to put them right at the edge of my table of values on the right. So my first coordinate, okay, so remember a coordinate is x and then y. So my x's all come from up here. Those were all my x's. My y's come from here. So my x value is a -2. That's my first x value. Oh, that's kind of crowded. Let me move that over a bit. Whoops. Fix that. That was a 5. Okay, so I'll actually color coordinate this a bit better. So my x value was in green there, and that was a -2. That was my x value that I subbed in. And when I did that substitution, I got this value here of y equals 5, right? That's what I got. I got y equals 5. So my y value, that's the red one here, that's a 5. Okay, so that is my first coordinate. Now my next coordinate that I got, here's a bracket to write my ordered pair or my coordinate. The x value, what's the x value here? The x value, so look way over, this was my x value for this coordinate. I subbed in a -1. That's what I subbed in for my x value. And when I did that, what did I get for y? I got 3. So there's my next coordinate. So you should have the hang of it now. Press pause and get the last 3 coordinates yourself. All right, great stuff. I'm assuming everybody got these. We got all the x's from here, we got all the y's from here, and we put it all together and we have a coordinate. We have a coordinate now. So that's great. Now we can plot them. Now we can do something with this grid that's sitting over here. We're going to plot the coordinates. So to plot the coordinates, I need an x-axis and a y-axis because I don't know where to put them right now. I can't just stick them out in the middle of nowhere. I need an x-axis and a y-axis. That's going to be my x right there through the middle. So I've got to put an x there. I have to label the axes. And sorry, there's my y, oh, a little crooked there. There's my y-axis right there. So you have to use a ruler for x and y axes. Have to. Look up here at the top. Remember in the definition, we've got the word linear here. We're talking about straight lines. That means ruler. Absolutely. You will lose a mark every time. You'll lose a mark for form every time you don't use a ruler. That's a lot of wasted marks for just not using your ruler. Okay, where are we on our list here? Table values, we did that. Number 2, write the coordinates, we did that. Number 3, plot the coordinates, we're doing that. Okay, I'm going to use blue. Well, before I can graph these though, my coordinates, I need a scale. I need to know where I'm putting them. And so what do I want to count by tens here? Would that be reasonable? 10, 20, no way, that's no good. We don't want to count by tens. These numbers, when I look at all these numbers in my ordered pairs here, they're all pretty small. I can count by ones. Sometimes we get really big numbers and we need to adjust our scale and we'll get there. But right now, these are all pretty small. So I'm going to count by ones. And remember what I told you before, however I count one way on the x-axis, I have to count that same on the negative side. So these are all, and I can't stop. I have to go right all the way through. So for example, I can't just put a -1 here and say, oh, that's good enough. I don't need to do the rest. Yeah, you do. There's another form mark, -1. I forgot to put I didn't label all my axes all the way. Now you can make it a little bit faster for yourself by not labeling everyone, and we'll do that on the y-axis there. So when I go to do the y-axis, I'm going to skip, but I'm still going to count by ones. This one is a 2. 4, 6, so that's a lot faster, and -2, -4, -6, and I can fit one more on -8. So that makes it a little bit faster to do it like that. All right, 2, 5 is my first point. How am I going to plot 2, 5? So remember what we did earlier. This is your x, this is your sideways motion, this is your y, this is your up and down motion, and you have to do the sideways first. So starting at 0, I have got to go over to -2 first, and then I go up 5, and my dot's going to go right there, and I will use blue for that. So -2, 5 is right. I'm just going to put a dot. I'm not going to write it out. I'm not going to write the ordered pair out, negative 2, 5. I'm just going to put the dot. Next one is negative 1, 3. Negative 1, 3 means to the left 1 and up 3. Put your dot there. The next one is 0, 1. Now, sometimes with the zeros it gets a little tricky, so let me just go through this one. 0, 1. My x values is 0. That means I start at the origin. I'm not going anywhere. I'm staying right there. I'm not going sideways anywhere, but I am going up 1. So I'm going to put a dot right there. 0, 1. And my fourth coordinate, look at this, we're almost done. My fourth coordinate is 1, negative 1. That means I'm going to the right 1 and down 1, and there's a dot. And I notice my dots are lining up, which is great because they're supposed to line up, but the question said it's going to be linear. My last one is 2, negative 3. My x is a 2. There's my x value of 2. And then down 3, put my last dot there. 2, negative 3. There we go. And that is step 3 done. So looking over to the left here, that's step 3 done. Step 4, connect the dots. You get out your ruler. I'm going to try with my ruler, and it's probably going to get jumpy and everything, but I'm going to try. I'm going to press pause actually while I try to do it. So if it takes me a long time to do it, you don't have to sit there and wait. So while I do mine, you do yours. Okay, you don't want to know how long that took me to do, and I'm not going to erase this chunk here because when I do the whole line erases, so just pretend that little scribbly bit's not there. So notice that I went beyond my 5 points that I graphed. I didn't just start and stop here. I extended my line, and that's really important because these x values that we picked, they were, they're pretty standard to pick, but I could have picked a negative 3, which would have given me this point, or I could have picked a negative 20. So these points are easy to sub in. They're negative, 0, and positive, which makes them pretty straightforward. But our line does continue in both directions to infinity. So we extend it a bit on either end beyond the dot, the last coordinate, and then we put arrows on. So, sorry, look at step 4 here. We connected the dots. I did that. Took me forever. Step 5 is ruler, label, and arrows. So I did the ruler, and now I'm going to do the arrows. The arrows indicate, whoop, that should be blue. The arrows indicate I'm going on to infinity there in both directions. The line continues and continues and continues. I just drew a tiny little chunk of it, but it continues, so the arrows have to be there. You forget your arrows, -1. You're losing another 4 mark. And if you don't use a ruler, of course, there's a -1. Now the last thing on step 5 says label. So label is because, especially when you do your homework, you're going to draw several lines all on one set of axes like we have here. You might have another line up here, and you might have another line down there. So we label it, and the way we label it is with the title of the line, and the title of the line is its equation. So this is my label here. So somewhere on the line, and if I could, well, I'll try to write it on an angle, but this tablet's not that great for that. But let's see if I can write it on an angle here. I'm going to write y, no, y, okay, wait a sec. Okay, y equals negative 2x plus 1. I've labeled my line. And that was the last thing on my list here for step 5, was to use a ruler to label and put arrows on. So I've done all that. So there you go, a beautiful line, except for this piece here. We've got all we got was this equation. That's it. We were given an equation, graph a line. So we truly got something out of almost nothing here. So we have an equation. We got these x values. We subbed them all in. We got y values. Once we got the y values, we put them together as a coordinate. We figured out where they went on the Cartesian plane, and we drew the line. So this little lesson here is this example is something you may need to watch over and over again, and it's super important. It's really important that you can draw a straight line perfectly from just a given equation, that you can put it on there. So that was a long lesson, but it's really important, and now we're done, and you have some homework questions to do. So get right to it, and let me know if you need help.